All right. So thanks everybody for being here today. I hope you're enjoying the conference. My name is Vincenzo Chianese. I'm an Italian software developer, and during the day I work for a company called API, which is a company that provides you a powerful API design stack for people that are developing, consuming, and designing APIs. If you ever had to craft any API, and by API I mean Web API, HTTP-based API, REST APIs, API could really be a cool platform for you. And the reason for that is that basically most of the API tools out of the market so far are really focusing on the runtime part of the API. How to scale an API, how to manage an API, how to secure an API. API is focusing more on the design part of the API, that is from having an idea to getting an API done. Those are my references. I have a GitHub account, a Twitter handle, and a blog where I try to write the things that I've been working on lately. Just totally out of interest, anybody in the audience that knows or uses API? Anybody that is paying for API? I had to try it. So what I want to talk and share with you today is the experience that we as a company and me personally have gained during 2 years working with API managers, API producers, as well people claiming to be API architects, and sharing with you the problems that they encounter during their journey. And just a couple of numbers about API, and I'll explain why in a bit. We have almost 300,000 APIs on our platform, which are being developed by more than 200,000 API designers. And together, there is a user base using APIs for more of 2 million API developers. And the reason to give you those numbers is not really about bragging myself about the company and the success, but more to show you that we work on API on a daily basis. This is really our job. And we have got tons of users that are building APIs. We've got tons of customers we were looking at. And we are kind of trying to instill some understanding about the problems that you get when you're trying to build a lot of APIs. And let's get into it. But at first, an important forward. Most of the APIs out there are actually non-public. When you think about an API, typically the people think about the big one giant API like the Twitter API, the GitHub, the Facebook API, as well, generally speaking, business models around the APIs. As an example, let's take Stripe. But for most of you in the audience, and I also would say for a big slice of software developers, the APIs, again, web APIs, are typically something that you use within your company. Today, with the world of microservices, you use the APIs as more an architectural strategy rather than having an API in order to expose something to the public. And you really have to employ a totally different strategy from when you have tons of internals API or when you have one big giant API. And just to make you an example so that you can reason about, today we are trying to experiment a new way to build the software, which is basically trying to split the monolith into microservices. And the concept behind this idea will be, I want to remove the complexity from my code, so I want to split my application into multiple parts that can do one thing and do it in a good way. But unfortunately, you can't really remove the complexity. But what you can do is move the complexity from the code to the network layer. Because when you have an application split into multiple services, you have to make sure that, for example, responses for multiple microservices are sequence correct. You have to handle the errors. What if one of my services is failing in the middle of the chain? How do I make sure that all of these are always up and working? So we don't really have to care anymore about the complexity of the code when going into microservices, but there is a totally new set of problems that you should remember, and those problems really reflect the way you build the APIs, as well defining the interfaces and making sure that you're not missing the data, but you're not leaking the data. So to start up with, let's say in your company you have successfully delivered your first API. Oh, and just to set out the terminology, I kind of hesitate to say the word microservice, basically because nobody really knows what a microservice is today, as well with the REST API. Nobody really knows what a REST API is neither, I guess. And so in this presentation, I will talk about internal APIs. Let's put it in that way, and then you can elaborate and dream on what's behind this API. A microservice, a monolith, we don't really care about this today. So to start up with our story, let's say that you have successfully delivered your first API in your company. And when I say successfully delivered, I mean it has been shipped, it has been deployed, it's stable in production, so it doesn't crash, it's documented, and you have multiple API consumers that probably are your coworkers using your API. And it's all fun and games when you have just to build a single API. And it's really easy to follow the agile methodologies or to make sure that the continuous integration is working properly when you have a single API. So given that you had this great success in your company, your boss says you know what, I want you to be in charge to make your second API for the company. And then you repeat the thing. You build your second API, you ship the API, it's stable in production, it's documented, and again, you've got coworkers, consumers, in our terminology, that are using it into their application, and are happy with that. But when you have 10 APIs, or when you have 100 APIs, or when you have 1,000 of APIs, and don't be scared by these numbers, because as of today, I can totally confirm that, for example, Microsoft or Autodesk are absolutely above this number. When you have all those APIs, well, you really need to change the strategy. Because, and the problem is that usually when you look at the literature out of the web, when you look for articles, you really can find just the lessons learned by people building and sharing opinions about big and giant APIs. But again, when you're splitting your organization into tons and tons of APIs, the strategy you should employ, it's absolutely different. And as a first step, you as an API architect, because you got promoted probably, you think that the best way to scale your API flow is simply to multiply the resources at your disposal. So the first thing you do, you hire more people, and then you create more API designs. That means you kind of think each API should be totally isolated, and it should only communicate with the external through its interface, which is ultimately true. And then, given that you want your API to evolve, every time you introduce a breaking change, you're basically creating a new version of the API, and then you start to deploy the API to multiple environments, so you have the V1 here and the V2 here, and you absolutely are having different problems. For example, if you want to keep multiple API versions keep running on the same time, you have to make sure that if I create a resource in the V1 version, I should make sure that it's readable and understandable also in the V2 versions, on the version 2. And so, again, as a first step, you try to simply multiply the resources at your disposal, just to realize that after a certain amount of time, then unfortunately this won't scale. And you start to look into the problem, and usually the first problem that the people see is the technological stack. Every time you have to craft an API, you start to have head hitches and say, do I really have to make an API? Can't I just use GraphQL or probably, why not JSON RPC, which is riding high again as today? But what I can tell you absolutely as of today is that changing the stack won't help, because that's not the problem. And also, before even trying to explore other ways and trying to say, I want to avoid to create a web API role for this service, just keep in mind that APIs will stay with us for a lot, and you're always using an API, even if you don't realize it. If you don't realize that you're using an API, it's because you're using a great API. So let me just open and close a bracket for a couple of minutes to try to remind you why we will stay with the APIs for a lot of time. And the best example that I can give you, it's really from a question that has been made decades ago. So let's say that we are able to travel into the space, and during one of our travels, we found aliens. But we are even more lucky. During the same days, we find two different species of aliens. And then the question will be, those three human beings are sit together, and how would those completely unrelated beings communicate? How would beings that never met each other actually communicate? And the answer is pretty simple. They would have to figure out on the spot. They would have to sit down, work together for hours and probably years, trying to establish a shared understanding and using it as a communication media. And while these scenarios is absolutely far in the future, it's not actually that far if we replace those fancy emojis with a computer, with a tablet, and with a telephone eventually, each of them running a different operating system or probably a different application. The question would still stand. How would totally unrelated devices that are totally unaware of each other and that never met each other communicate? And the answer will be the same. They would have to figure out somehow. But unfortunately, we are not there yet. While the artificial intelligence is moving forward, the machine learning is moving forward, as of today, we can't really program devices that are able to discover how to communicate with other devices on the spot. Probably in a certain point in the future, but not today, and probably not in 10 years. So we need to work around the issue. And the way we work around the issue is establishing some a priori understanding which is installed into the devices before those devices even met. So this shared understanding ahead of the time, it's what we call an API. And again, this is the reason why we will stay with APIs for a long time. And even if you think you're not using an API, you're always using an API. Given that, let's close the brackets and let's go back to our original question. So you multiplied your resources and it didn't work. You considered to change the stack, but fortunately you discovered that probably it's not a good idea. And probably the question that you should ask yourself is more something like, is your API flow scalable? Am I designing and developing my web APIs in a way that is scaled when I have a large number of APIs, when I have to spin up APIs in days and I have to shut them down in a week? Well, in order to understand this thing, let's try to have a look how usually the API usage flow should look like. So having a shared understanding ahead of time means that I have a device which is exposing an interface. And then a human will come and write a lot of documentation about how to use the interface. And then on the other side of the ocean, I have my client, my customer, my consumer, which will read the documentation and then program the client. But unfortunately, this is not reality. So far, for the experience I had so far, the usage of an API, it's usually something like this. So there is still somebody that is exposing an interface. Then a unicorn will come and document the thing. Then somebody will try to program the client. Probably he will fail, and only then he will realize that probably a good idea would be to read the documentation. So why? The question would be why the API usage flow is broken. And it's simple. It's because the way we do the APIs in 2016. The 19% of all our efforts in building the APIs, it's concentrated into 4 steps. And it's the development, the delivery, the consumption, and eventually the analysis. Just to make it clear, honestly, I didn't see a lot of people doing the analysis, analyzing the usage of the API. But I want to be a good guy today, and let's say that everybody is doing the analysis of the API as of today. But, I mean, out of this room, everybody is really concentrating on the development, delivery, and consumption of the API. And this flow is broken. It's absolutely broken. It has got pain points. And let's get into it one by one. And the first one is, of course, it's error prone. There is so human work involved that people are simply making mistakes, and that's okay. We are human. And also, the resulting system that you have, it's brittle and it's tightly coupled, because by definition, the API, it's a shared understanding ahead of the time. So generally speaking, good luck changing it. Every time you're changing this shared understanding, you're breaking the client. And if you don't want to break the client, what the people do usually is to version the API. And version an API means creating a new shared understanding. And again, this is a breaking change. It means that, of course, the system is coupled, and you have to redeploy the clients, making sure that everybody's using the latest versions, and so on. And also, it requires you a couple of iterations to get it right. Because in order to understand if you're satisfying all the requirements, you have to build the API, you have to deploy the API, and you have to make sure that your customers are using the API, just to realize after a certain amount of time that you're probably solving the problem that your coworkers don't even have. Or they are using your API in a very creative way, which sometimes is good, but sometimes you really want to make sure that they are using it in the way you designed it. So the only thing you can do is iterate on the API again, changing the system, redeploy the clients. Hopefully you didn't make any breaking change yet, and keep going. And this is the reason why it doesn't scale. It's because every time you have to change something in your API, you have to go through the steps, all the steps again. The good news is that we can prevent or mitigate those problems by rethink the API flow we are used to. And this is what I would like to show you today, a different API flow, and it is really rotating on one basic concept, and it's the design first, of course. Back in the 19s, when even the term API had a totally different meaning, the APIs were really a byproduct. The only reason to have an API in your distributed system, it's because you wanted to do the things distributed. So you were exposing some methods for your coworker, probably just telling him the thing by phone or by email, and he will just use the method and everybody was happy. But then after decades, people realized that probably it was a good idea to stabilize the exposed interface and document it. But unfortunately, usually the developers don't really like to write the documentation, and they started to use those systems that are able to come up with documentation out of the code, and the word was saved. But guess what? The documentation suffered, and more important, the consumer experience will suffer. Because when you are auto-generating the documentation, you are relying on the thing that it's always up to date auto-magically. But what you are really generating, it's not an API documentation. You are generating an API dictionary, a reference. You are telling to your customer how you wanted to call the classes, how you wanted to name the parameters of your function. While on the other hand, when I'm reading an API documentation, I want to know how to get started very quickly. I want to know how you're ending the error. I want to know, I want a code example that I can copy paste into my code and verify that the API is working properly. But fortunately, today, in 2016, APIs are really treated as a product. And the best example I can give you here is Stripe, the payment gateway. Hopefully, you should be familiar with. And the reason why Stripe is really hiding right, in my opinion, it's not because of their pricing model, it's not because of their great web application, but it's because they really have a very well crafted API. You don't even realize you're using an API. And also they have a great documentation, really a great documentation. If you go to their website, you're just one copy-paste away from your first real API call. And this is really a great way to onboard the developers. And actually, also, you can see that there are a lot of companies that are becoming API first. They are selling you their platform API, not really the facilities and the tools around that. And one example, it's a Stripe, or also Parse was one of them. Unfortunately, it was shut down. But the lesson here is that in 2016, APIs are products, so treat it as a product. Hopefully, we know how to craft software, and we know that software goes through a design phase, and the same goes with an API. So if anybody's coming to you in your company telling you, hey, we need an API, just stop for a moment and please just resist the temptation of simply fetching the data from your database and shoot it down into the network as a JSON payload. But unfortunately, it's still a waterfall. Even if we design the API first and we put all our efforts in designing the API, we still have a problem. If I realize during the journey that my assumption about my API were wrong, basically the only thing I can do is modify the design and change the development of the API, deploy the code change, and then make sure, hopefully, that this time everybody's agreeing on the exposed interface. How do we prevent this? And the best way is, of course, is prototyping. You don't really have to write any code when you're building an API. You can create a stub implementation of your API. When you think you have a good blueprint, a good idea, a good blueprint of what you think it's a good API, you can create a stub implementation without writing any code and give it away to your customers, to your coworkers, so that they can use it and eventually make sure that they agree with the exposed interface, make sure that it fulfills their use case. And if you just realize that you made a mistake, it's totally okay. You are iterating on the design phase. It's absolutely okay to reiterate because you didn't write any code at all. You can modify the prototype in 3 days. You don't need to write a test. You don't need to scale it. You don't need to secure it. And thanks to that, you can analyze and iterate on the prototype as much as you want, as long as everybody's agreeing on the contract. So, yeah, analyze and iterate. So with those two main concepts, design first and prototype, this is what we do believe is a better API flow for 2016, regardless of the type of API you want to build. If you want to build a private API, if you want to make 1,000 API, or even if you want to make one big giant Facebook-like API, it doesn't really change. But I would say it's kind of mandatory when you are going beyond 5 or 6 APIs. And it's divided in several steps. And one is the preparation, the design, the development, the delivery, the consumption, and the analysis. And as you can see, compared to the current flow, there are 2 more steps, the preparation and the design. And now let's go through all of them in more detail. So the first step is the preparation. And so far, it's the most underestimated phase I've ever seen in an API design. And it starts with the most important step, which is the definition of the domain semantic, which is a fancy way to say, name the things. Just to make you an example, is that a chair? Is this a chair? Is this a chair? Well, this is absolutely not a chair, but maybe for somebody it is. I can definitely sit here if I want to. Or also, let's say I want to build a coffee order system. What is a coffee for you? Are you speaking about the ready-to-drink hot cup? Are you speaking about the beans? Are you speaking about the grains? This is particularly, usually you might think that it's easy and even trivial to define your domain semantic. But when you have multiple teams, as your organization grows and it's spread around the world probably, you will see that people will start to name the things in a totally different way. Probably just to realize after 3 or 4 days that everybody was referring to the same thing. I'm quite sure if you take your people and you sit down in a room and start agreeing on naming, you will probably spend months and months, or even years. So it's really important that everybody's on the same page regarding the name. As a next step, you have to choose an architectural style for your API. everybody today is claiming to do REST. We are doing REST API. It's easy. Well, in my opinion, nobody's really doing REST API, at least in the way the original author was promoting it in 1999. And what everybody's doing today, it's some flavor of REST, what I like to call REST-ish API. And it's kind of okay. You don't have to do REST API if you don't need to. But what is not okay, it's claim to follow an architectural style without accepting the drawbacks and without respecting the constraints. If you have to spin up an API that should probably just stand for 3 days for an event like this one probably, it's okay to not use any REST or any other sophisticated architectural style, as long you know that you can deploy and write the code in 3 days, but then good luck making changes to the API. On the other hand, if you want to make an API that should be really stable, robust, ready to change, it should last forever, probably REST could be a good choice for you. But regardless of the choice you want to make, pick the right architectural style and make sure everybody's understanding it. Because if not, it doesn't matter the architectural style you're choosing. The developer experience will suffer because the people will start to make assumptions that won't be true. And one personal example I can make is that every time I read about an API claiming to be REST, well, from my personal point of view, I am expecting to find a payload which is HAL plus JSON or a Siren payload. And so far, I didn't really find it. And this is breaking my expectation. But that may vary for you, of course. That's just my personal experience. So pick an architectural style and make sure to respect it and make sure that everybody understands it. And then standardize. This is the step where you want to decide, for example, how you want to craft your URL, URI templates. Or if you want to use camel case or kebab case, if you want to use British English, simplified English, British, American, it doesn't really matter. Or also how you want to handle the authentication of your API, how you want to handle the pagination of your API. And you will reuse those definitions because when you are building a large number of API, you want to make sure to have a consistent experience, which means if I treat the pagination in a certain way, it should be the same in all my APIs. If not, the developer experience will suffer. So standardize the thing, and it doesn't really matter the choice you make, but what's really important here is that once you find a standard, you should really stick to it. Then the next step, which is design and prototype. And as you can really see, we are not even getting started to build an API. So from the previous step, we gathered a list of terms, thanks to the definition of the domain semantic. Now what you want to do is to look at all of those terms and try to identify the resources that you want to expose from your API. You want to look at these terms and try to say, this is a coffee, this is a resource for my API, and I want to expose it. Then you want to identify the attributes of your API, the data associated to your API. Then, once you get your resources identified, you want to define the status of your resources. And here, what can really help you is to try to draw a finite state machine diagram. And I'm quite sure you should be familiar with it. And what is that? It's really a diagram that for each resource, it's drawing all its states and the action I should afford in order to move from a state to another or to reach a particular state, as well understanding the relationship between the resources of my system. If you take the time to draw this diagram, you will have a really clear understanding all of your resources in your system and the relationship of the resources. And then, and only then, you can finally start to formalize the thing and write the things you agreed so far into an API description document. There are a couple of API description documents. We in API auto-read and promote one, which is the API blueprint, and for some reason we do believe it's the best one, but that's not really the point. You can use Swagger, you can use RAML, or eventually you can also use a plain document. It's fine. You will lose the automation that you can get using the API description languages, but ultimately you will still reach your aim, which is agreeing on the things. And then you can use the mock server. You can create a stub implementation from the API description automatically. You can feed a little program with the API description that you've wrote and formalize it, and it will spin up a small static mock server. Yes, it's a static mock server, but still it behaves exactly in the way you specify it, and you can give it to your customers. So while you're still writing your API description, your formalization of your API, you can already start to give it away to your customers and say, hey, what do you think about this blueprint? Do you think it's satisfying your use case? And then really share and review the document. And here, I really suggest you to embrace the GitHub flow. Because what is great, what I really like about the GitHub flow, it's not really the issue or the pull request, but what I do like of the GitHub flow is that it really gives you clear checkpoint in the life cycle of the software where everybody should stop and synchronize and collaborate through the code review. And so far, it's proven to be really useful. And given that embracing the GitHub flow, I really suggest you to put the document into the same repository of your backend implementation. And I will explain you why in a bit. So share and review the document, and here you can really involve everybody you want in your API design. You can involve your programmer that already know your backend system and can tell you the pain points he might encounter. You can bring in your technical writer so he knows what's going on, and what he should be ready to document. You can bring on also your designers so that they can eventually prepare an HTML page in order to accommodate documentation. And then, as a final result, you have a contract, which is the central point of your API. You have a contract, and everybody, if you share it and review the things together, everybody is agreeing on the thing, and everybody is aware of what's going to happen in the system. And now, and only then, you can finally start the development of the API. At first, the contract, of course, is the starting point. And then, as I said before, I really suggest you to put the contract in the same repository of your backend implementation. Why that? Is that when you're developing the code, you want to keep checking that what you are coding is being done according to the contract. You want to keep checking that the changes are made according to the contract. And you can do that today. With API Autoread an open source tool that it's called Dread, and it's bringing the justice into your API. What it does, it takes your backend implementation, it spins up an instance of your server, and for each thing that is wrote into the API description document, it's trying, if your backend implementation is respecting the contract and underlying the discrepancies. So you can also see that as a kind of test-driven development, where at the beginning, you just have the contract and you don't have any code, so basically you have all the failing tests. And as you keep going, writing the code, you will see that some tests will start to pass, and at the end of the journey, hopefully all the tests should pass. But what is really great about that is that you can detect the breaking changes, which is great. So if you put your system under a continuous integration, what you can do is that every time you push something into your code, regardless of the source, if you change something in your code, if you change something in your contract, you can always, the change gets tested. And you can know really in real time if the code is breaking the contract or if the contract is breaking the current implementation. So it won't help you to make the change, but at least it will help you to detect the breaking change and making sure you don't propagate things that will destroy the client experience. And then, of course, when you're done, you should probably you should probably deploy the thing, and there are plenty of tools that you can use. You can use the Heroku flow, for example, or whatever suits for you. Then, once your API has been developed, now it's time to deliver it. It's time to onboard developers. But the great thing here is that given that your developers were probably part of the design of the API, they were part of the contract, they agreed on the contract, they should almost be ready to use your API. And so the best thing you can do is really just share the API description document. It's all you need. You can eventually share the documentation, but with probably a smart console or interactive stuff on it, but it's just an HTML rendered version of the documentation. The API description document, it's really the central point. And also, given that, again, it's in your same repo, you can, the only thing that it's limiting you, it's the fantasy. Just to give you a couple of examples of real-world usages, what customers are usually doing is that every time a change in the contract reaches the master branch, they are updating the mock server automatically. Or also, when they detect a breaking change, they are sending a mailing list saying, hey, we made a breaking change into your API, into our API. You probably might be interested in having a look into. Or also, regenerate your HTML documentation, or eventually rewrite the tutorials. I mean, the fantasy is the only thing that it's limiting you. More you depend on the contract, more easy it is to stay up to date. And then, of course, for your API, don't forget to use management tools. You probably might want to secure your API. You want to limit the API. You want to make sure that you want to invoice your API, probably. That's really up to you. There are a lot of companies that are doing a great job. Pick the one that suits best for you. And now, let's go to the other side. I am the client developer, and it's time for me to write the client. And there is no shortcut here. Somebody must really read the documentation. If you don't even try, well, what are we even talking about? But what you can do as a backend guy, I mean, as a person working on the backend implementation of the API, you can provide a way to experiment with the API. Because, for example, let's say I have an endpoint in my API, and in my contract, I just wrote, hey, in order to hit this endpoint, you have to provide this particular header in your HTTP request. If not, the API call would fail. So I have this small requirement which is into the contract. What I can do, I can eventually provide a smart console like Postman or Po, choose the one that you like, and make sure that you can't even perform the request if you're not providing the headers I'm requiring. And everybody knows that because it's specified in the contract. If you reach this level, you're not really you're not checking raw HTTP calls, but you're making sure that your HTTP calls are semantically correct, that you're giving the data I need, that you're giving the headers I need. And in meantime, while I'm developing on the server, you can use the mock server that is provided for you. There are multiple choices that you can use today. We in API, for example, we provide you a free, totally free mock server. So if you copy-paste your API description document, you get in 10 seconds a mock implementation in the cloud for free, and you can use it as a starting point for your client developers. And what if what if me, as a client developer, I am still in trouble? So I don't understand why this API call is not working correctly. What you can do, you can put eventually a proxy server in front of your production server, recording the API calls and checking every single API calls with the contract that you agreed on. Discovering, for example, that people is missing a key in the JSON payload. It's missing an header. And you can really help them to troubleshoot this kind of problem. And in the end, of course, the analysis phase. I will spend a couple of words here, but it's really important. And the idea here is that you want to, for example, make sure to collect the feedback from your customers, even if you had them in the past during the design phase, or also put some metrics into it. Because, for example, you might discover that some endpoints are being abused, and you might want to split them, or some endpoints are totally unused, and probably you should revisit those ones, deprecate, remove those ones, or eventually reiterate on the design flow. And you can iterate on that as long you move on the design phase and using the prototype, using the mock server, you can evolve the API and already starting to write the code when you're sure that it's time to change. Well, of course, I don't want you to watch this record every time that you have to build an API. So what we did, we created a small website, which is really a summary of what I just told you. And it's on the API website. You can definitely have a look into. And you can, all the phases that I just told you are summarized in this page. And given that I still have 9 minutes, which should be okay, I just wanted to make you a really, really super quick live demo and try to show you how, thanks to the API description document, how the description document can help me on the backend side and on the client side as well. So let's try it, and let's hope that everything is going to be okay. Kaboom. Is that visible for everybody here? No, right. Zoom in. How about now? Nobody's complaining, so I will say it's OK. So let's say I have a small API that I have to develop, and we already agreed on the contract. And this is the contract, and it's written in API blueprint. But again, that's not the point. You can use Swagger. It's absolutely fine. And the first thing, now I'm using Visual Studio Code here, and as I can see, I installed a plugin that I personally made, and it's able to bring you some facilities for API description document, for Swagger and API blueprint. As you can see, I get syntax colorization as well. If I make some mistakes, I get the validation of my API. For example, if I make a typo here, I can see, hey, this API is not valid because blah, 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 blah. And I can close it. And also, when you have really large API, I can, for example, navigate through the action, which is really useful sometimes. But OK, let's keep moving. This API is really simple. It has got 3 endpoints. The first one is returning me the status. So status OK, uptime, the uptime of the server. And then I have a method which, using a new URI template, I can basically set a user into the system. And then the last endpoint, it's telling me, hey, with this endpoint, user current, you can get the last user you just set in the previous endpoint. And I just implemented these 3 things into this simple Node.js application. It's here. And now, me as a backend developer, I'm the person developing this API. I want to make sure that my work so far, it's going well according to the contract. So if I open the console now, and I type test, which is using Dread underlying. The underlying testing framework is Dread. And nvm use 6. And I try to test my API. Now what Dread will do will spin up my server, and for each of the action, it will try to make sure that the responses and the requests are all semantically correct according to the contract. So let's give it a try. It's spinning my server. Let's see what happens. And I got a filing test. So what's going on? If I scroll here, you can see that it's telling me, hey, the expected things that we agreed on the contract is that I should have a content type as an header, and as a body, you told me you will send me a status and an uptime JSON field, while the actual thing that you sent me is just a status. You're not fulfilling the contract. That's an easy fix. Let's make it live. And let's try it again. And this time, hopefully, it should say that I'm respecting the contract. And the test passed. Was really a super simple example. Dread is definitely more capable and complicated. But it's just to make sure how you can really simply make sure that you are working in the way you specified in the contract. And now let's go to the other side. Let's say I am the client developer, and I'm using the API, and I'm facing some issues. So I'm spinning the server here, which is listening on the port 8018, if I recall correctly. Yeah. Now let's make it from here. So I want to try to set the latest user in my system. So what I do, HTTP localhost 3000. Let's open the document here. It's users, and then I can specify users. Let's write test. All right, it's 1818. Here we go. And I get unauthorized. Why this is not working? Well, the error is kind of really clear, but let's say I didn't read the API description document. I don't know what's going on. How do I make sure that I, as a client developer, I'm respecting the contract? I'm doing everything as you said, as we agreed in the contract. What we can do, let's make it now on the fly. I have the last 3 minutes. Is that I can use, for example, I can use the smart console that, for example, we in API provide, and let's try to troubleshoot this error. So I can use the mock server. Let's try to reply the same request, just changing the endpoint. So again, cur, blah, 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 blah. And this time, it's returning a value. And of course, it's a mock server. It doesn't have the logic. But what I can do, if I now go back to the console, and I go to the inspector, I can see that there was a call made a few seconds ago. And if I open it, I can see there is a red warning here. Hey, you're missing the X out custom headers, which has been specified into the contract. So if not working, it's because you didn't read the contract. And is that true? Well, yes, it is. So let's try to make the things in the right way now. So -h X out equal should be in this way. And it's now working correctly. So now, thanks to the smart console that you can develop on your own, you don't have to use the API one. You can use POW, you can use Postman. They support the API description languages. You can really see how easy it is for both sides to make sure that it really helps you to troubleshoot the things. It moves the moment of the truth as fast as possible, as in the earliest moment possible. So I guess that's all I have. And regardless on the way you want to build your API, regardless of the description document you want to use, good luck with your API. That's all I have, and enjoy the rest of the conference. Well, I'm out of time, so if you have any questions, just ping me personally. We don't have to make the Q&A right here.